Okay, students, as per Darcy-Weisbach formula, so HF is equal to 4FLV squared divided by 2GD. So HF is equal to loss of head due to friction. Okay, HF is equal to loss of head due to friction, that we already seen. And F is the coefficient of friction. So if you want F means we need a Reynolds number. So without Reynolds number, we can't get the F value. So for calculating the Reynolds number, we need a formula. So that formula is BD divided by nu. Okay, V is the velocity, into D the diameter, and divided by the kinematic viscosity. Okay. So from that RE, Reynolds number, based on that Reynolds number value, if the Reynolds number value is less than 2000, means you have to use 16 divided by RE. Okay. Or otherwise, this Reynolds number is between 4000 to 1 lakh. That means 10 power 6. Means you have to use 0.079 divided by RE power 1 by 4. So where L is the length of the pipe, okay, and B is the mean velocity. Mean means average velocity, okay, of flow, and D is the diameter of the pipe. And the chassis formula, what is the chassis formula? V is equal to C root Mi. Okay. So C is the, V is the velocity, and C is the chassis constant, and M is the hydraulic mean radius. Here I given the definition. This is important 2-mark definition. So the ratio of cross-sectional area of a channel or pipe in which a fluid is flowing to the wetted perimeter of the conduit. Conduit means that pipe. Okay, that means area divided by perimeter only. So which is equal to D by 4. Okay. Next, I is the loss of head per unit length. Unit length means 1 meter, like that. Okay. So that formula is HF divided by L. So this is the chassis formula. So now we will go to the problem. So this problem is very, very important. I request all of you, please watch carefully. So find the head loss due to friction. Find the head loss due to friction in a pipe of diameter 300 mm and length 50 meter. So here diameter is given 300 mm and length is given 50 meter, through which water is flowing at a velocity. Velocity is 3 meter per second. So here the velocity means average velocity they given. Okay. So Darcy's formula. As per Darcy's formula, what is the loss of head, and chassis formula? What is the loss of head? So from the both we have to calculate. So which is C is equal to chassis constant equal to 60. Okay. So take nu for water is 0.01 stoke. Okay. Okay. So here we have to calculate from the two conditions. One is Darcy's formula and another one is chassis formula. Take nu for water. That means kinematic viscosity. Kinematic viscosity is 0.01 stoke. So let us see how to solve this problem. First write the data given. So D they given in mm, you must convert it into meter. Okay, and the length of the pipe 50 meter, and velocity of flow 3 meter per second, and the chassis constant C is equal to 60, and kinematic viscosity they given in stoke. Okay, so remember first unit. Remember the first unit. Okay. So stoke, how to convert stoke into meter square per second? So it is, you have to multiply it by into 10 power minus 4. Okay, 10 power minus 4. Okay, next, first using Darcy's formula. So first write the equation. So this is the Darcy's formula equation. HF is equal to 4FLV square divided by 2GD. Okay. So next, what are the unknown parameter here? First you find the unknown parameter. Okay. So F is the unknown parameter here, and L is known 50 meter, and velocity known 3 meter, diameter D is known, it is 0.3 meter, and G 9.1. Okay. So except this F, all the parameters are known values only. Okay. So how to find that F? So for that F, we need Reynolds number formula. Okay. So for the Reynolds number formula, we already know RE is equal to B into D divided by kinematic viscosity. Okay, this is the formula. Now all the values you know. So what is B? 3 meter per second. Okay, it is given in the question. So next, diameter of the pipe also given 0.3, and kinematic viscosity mu also we calculated 0.01 into 10 power minus 4 meter square per second. Okay, so this is the final answer. 9 into 10 power 5. 9 into 10 power 5 is the final answer. So as per the discussion we discussed previously, if that Reynolds number value is more than 4000 means, what is the formula? We have to use F formula is 0.079 divided by RE power 1 by 4. This is the formula. So substitute the formula here. We already found RE value. Okay, substitute in this equation, you get F. Okay, F is the quotient of friction. Okay, so it is a dimensionless value. So already we know Reynolds number also having no dimension, and quotient of friction, it is a quotient, so there is no dimension. Okay, so it is 0.0256 only. Now substitute all the values in this HF formula. So 4 into F 0.00256 into L is 50 and B is nothing but velocity, average velocity, 3 square divided by D, 2GD. D is 0.3 and 2 into 9.81. Okay. So finally, head loss due to friction is 0.7828 meter. This is the head loss due to friction. Okay. So next, this is as per Darcy's formula. Next, we will go move to Chassis formula. So using Chassis formula, so HF is hidden in this item. HF is hidden in the item because I is equal to HF divided by L. So first we need to find I. Okay. So from this I, we can easily calculate this HF. So substitute all the values in this equation. You can see V is equal to C root Mi. So substitute V. What is V? It is the average velocity, 3 meter per second, and chassis constant. Chassis constant is 60, and the root Mi. M is D by 4. Okay, D is 0.3 divided by 4, which is equal to 0.075 meter. Okay. So always for all the problem, M, small m, hydraulic mean radius is D by 4 only. Okay, this is the standard formula for circular section pipes. Okay, so now I am substituting all the values in this equation. So V is 3, C is 60, and root M 0.075 into I. So from this equation, find out I. Okay, so I is 0.0333. This is the answer, I answer. Okay, so now I is equal to HF divided by L. Okay, so L length we know. So we need to calculate per unit length. Okay, per unit length. Unit means 1 meter. 1 meter, for 1 meter length only we have to calculate. But we having 50 meter length. Okay, the pipe having the 50 meter length. So how to calculate for 1 meter? So that HF divided by 50. That HF divided by 50. So using this formula, we can calculate for unit length I. So equating the two values, I is equal to HF divided by 50, which is equal to I 0.0333. So when I need only HF. Okay, so therefore HF is equal to 50 into, so multiply by these two value, 50 into 0.033. Okay, so this is the answer. Okay, students. So I hope all of you understand the first problem. So now we will move to the second problem. Okay, so in this problem, all the data are they given except the diameter of the pipe. Except the diameter of the pipe. Okay, so how to calculate the diameter? So diameter is hidden. So here they mention the chassis constant, and then we have to use the chassis formula, not the Darcy's formula. So using the chassis formula, we have to find the D. That means diameter of the pipe. So now, where is in which formula the D is hidden? In that M formula. M means hydraulic mean radius. So from that hydraulic mean radius formula, we know that the formula is D by 4. D by 4. Okay. So that diameter is hidden in the hydraulic mean radius formula. Okay. So let us see the problem. This is the outline of the problem. Now let us see the problem. Find the diameter of a pipe of length 2000 meter. 2000 meter. When the rate of flow of water through the pipe is 200 liters per second. Okay. So what is the other name of rate of flow? It is nothing but discharge. So here the discharge is given in terms of liters per second, and we must convert it into meter cube per second. Okay. And the head loss due to friction is 4 meter. So here in this formula, HF is given in the question. Head loss due to friction. Okay. Take the value of C is equal to 50 in chassis formula. So here they didn't mention any Darcy's formula. So you forget about Darcy's formula. Okay. So B is equal to C root Mi. So this is the chassis formula. Remember this formula only. Okay. So now what are the data given? Length of the pipe 2000 meter. Discharge Q is equal to 200 liters per second. So how to convert liters per second into meter cube per second? It is 200 divided by 1000. It is 0.2 meter cube per second. Next, head loss due to friction. HF is equal to 4 meter. And value of chassis constant C is equal to 50. So length of the pipe is 2000 meter, and Q discharge is 0.2 meter cube per second, and head loss due to friction HF is equal to 4 meter, and value of chassis constant C is equal to 50. Okay. So now we have to calculate the velocity of flow, because discharge is discharge only given. Okay, discharge only given. So velocity of flow. Okay, velocity of flow V is equal to discharge divided by area. Discharge divided by area. So now we can see the velocity. So velocity, how to calculate velocity? We don't want a discharge. We need only velocity. Okay. So the formula for velocity is discharge divided by area. So Q divided by pi by 4 into D square. So we don't know. So keep as it is. So discharge here, you can see discharge is 0.2. So 0.2 divided by pi by 4 into D square. Okay. So 0.2 into 4 divided by pi into D square. So this is the velocity. So we don't know the D value. Okay, so keep as it is. Okay, so next hydraulic mean that M is equal to D by 4. So here also D is the unknown value. Keep as it is. Next, loss of head per unit length, I value. So what is I formula? HF divided by L. So HF is 4 meter divided by length of the pipe is 2000. So we need only per meter length. Okay. So 4 divided by 2000, we get an answer 0.002. Okay. Now chassis formula. Write the chassis formula. So we know that chassis formula is V is equal to C root Mi. Okay, so substitute all the values, whatever you found in previous, substitute all the values in this equation. Now tell me what is V? V is nothing but this one, 0.2 into 4 divided by pi into d square. So here you can see I substituted here. Next is C. C is chassis constant. It is given in the question, 50. Next, root of M. M we don't know. We only know the formula because D is unknown value. So D by 4 into I. I is nothing but 0.002. We already found. Now simplify this equation. Okay. So this 50 goes to that side means 5D square into 50. This 50 goes to this side. Okay. So now squaring both sides. So I square this term and this term. Squaring both sides. So finally we got this value. Okay. So again simplification. Finally we found D is equal to 0.553 meter. 0.553 meter. That means if you converted into, so always we are telling diameter in terms of mm. Okay, so 0.553 meter, which is equal to how much mm? Into 1000. 1000 means 553 mm. So this is the final answer. Okay. So first write the formula and write down the known values. So in this formula, D is hidden in this velocity formula and M formula. So substitute as it is in this chassis formula. Okay. So finally, you can easily get diameter of the pipe. Okay, students. So I hope all of you understand the second problem. Now we will move to third problem. Okay. So this problem also an easy problem. A crude oil of kinematic viscosity 0.4 stoke. Okay, kinematic viscosity is given 0.4 stoke. Is flowing through a pipe of diameter 300 mm. So the diameter of the pipe is 300 mm at the rate of 300 liters per second. So here 300 liters per second is nothing but 0.3 meter cube per second. Okay. Find the head loss due to friction for a length of 50 meter of the pipe. Okay. So what are the parameters given? First you understand the parameters. So kinematic viscosity is given. So what is the need of kinematic viscosity here? To find the Reynolds number. So this problem, in this problem, we have to use Lass's formula. Okay. So kinematic viscosity is given and diameter of the pipe is given 300 mm and the rate of flow also given. Rate of flow 300 liters per second also given. Find the head loss due to friction for a length of 50 meter of the pipe. Okay. So kinematic viscosity V is equal to 0.4 stoke and we must convert it into meter square per second. It is 0.4 into 10 power minus 4 meter square per second. Okay. So always in the examination they will give in stoke only. In the examination they will give stoke only. So you must convert it into meter square per second. Okay. So we have to convert stoke into meter square per second. Means we must multiply by 10 power 10 power minus 1. Okay, so now diameter D is equal to 0.3 meter given, discharge 300 liters per second. That means 0.3 meter cube per second, 0.3 meter cube per second, and the length of the pipe L is equal to 50 meter. This is the overall length of the pipe. Okay, so now what are the unknown values here? Once you check the formula, so this is the formula. This is the formula. So F is not given, is the unknown value, and length of the pipe is given 50 meter, and velocity also not given. Okay, and the diameter is given, and the G we know 9.81. So in this problem, we need to calculate two parameters. Okay, one is F, another one is P. So let us find out first B. Okay, so once they given discharge and diameter, diameter means we can easily calculate the velocity. So what is the velocity formula? Q divided by area. Okay, Q divided by area. So Q is nothing but 0.3 divided by pi by 4 into 0.3 square. Okay, which is equal to 4.24 meter per second. So the Reynolds number RE is equal to V into D divided by mu. Nu. Okay, so V is the velocity. What is the velocity? 4.24 meter per second. And the diameter of the pipe. What is the diameter of the pipe? 300 mm. We converted into meter. So always you must convert it into meter only. Okay. So diameter 0.3 and nu. Okay. So nu is given. It is 0.4 into 10 power minus 4 meter square per second. Okay. So we got an answer 3.18 into 10 power 4. 3.18 into 10 power 4. So you can see, observe this 10 power 4. So it is greater than 4,000. Reynolds number is greater than 4,000. So if Reynolds number lies between 4,000 to 1 lakh, 4,000 to 1 lakh, the value of F is given by the formula. F is equal to 0.079 divided by RE power 1 by 4. Okay, so therefore 0.079 divided by what is the Reynolds number here? 3.18 into 10 power 4. Okay, so 0.00591 is the answer. Okay, so head loss due to friction. So based on this, we found the two unknown parameters P and F. So finally, head loss due to friction, HF is equal to 4 into F. F is 0.00591 into length of the pipe. L is 50 and the velocity. What is the velocity? 4.24. Okay. Next, divided by 2G D. D is 0.3. So substitute all the values in this equation. Finally, we got an answer 3.61 meter. So this much of head loss, okay, head loss occurs in the pipe. Okay, this is the head loss due to friction. So this is the previous case we used Chase's formula. In this problem, this third problem, we used Darcy-Weisbach formula. Okay. So now we will move to the next problem. Okay, I'll read the question. Please follow. An oil of specific gravity 0.7. Okay.
Sir, kinematic viscosity is sir, prati problem na?
Yes, they will give. Okay, next problem. So what are you have doubts? You can ask last.
First one real sir.
What are the doubts you can ask later because I am recording. Okay. So an oil of specific gravity 0.7. is flowing through a pipe of diameter 300 mm at the rate of flow 500 liters per second. Okay. Find the head loss due to friction and the power required to maintain the flow for a length of 1000 meter. Take kinematic viscosity mu is equal to 0.29 stokes. 0.29 stokes. Okay. So this is somewhat complicated problem. Once you know the formula, it is very easy. There are two steps out there in this problem. So I will read the question once again. So in this problem, they given specific gravity and diameter of the pipe 300 mm and rate of flow, that means 500 liters per second, and head loss due to friction. So we have to calculate the head loss due to friction and the power required. Okay, how much power required to maintain the flow for a length of the pipe. So pipe length is 1000 meter. So take kinematic viscosity. See, mu symbol is for kinematic viscosity. It is 0.29 stokes. Okay. So now let us write the data given. So what is the specific gravity given? 0.7. Diameter of the pipe is D is equal to 0.3 meter. And the discharge is 0.5 meter cube per second. And the length of the pipe L is 1000 meter. Okay. First, what are the unknown values? So F is not there. F is not given and velocity also not given. Okay. So first we have to find these two terms. So balance L is given, length given. So here you can see length given and the diameter also given. Okay. So as per previous formula, previous problem, we must calculate first velocity and second F. Okay, that is our first step. So now calculate velocity. So we know that velocity formula Q divided by area of the pipe. Velocity is equal to discharge divided by area. Discharge divided by area. Okay. So here discharge is 0.5. Okay. So in the examination, they always give in terms of liters per second. So you must convert it into meter cube per second by divided by 1000. Okay. So 0.5 meter cube per second divided by area. Area is 5/4 into d square. So d is 0.3. So finally we got an answer 7.073 meter per second. This is the velocity of flow. Okay. So that water, that liquid, take it as some oil. Okay, because the specific gravity is less than 1, they given. If the specific gravity is 1 means it is called water. So it is the specific gravity is less than 1 means it is other than water, somewhat oil. Okay, so in this problem, the given specific gravity is 0.7. So it is less than 1. Okay, so now RE is equal to Reynolds number is equal to velocity into d divided by mu. So 7.073 into 0.3 divided by what is the kinematic viscosity? So 0.29 stokes. You must convert it into meter square per second. That is 0.29 into 10 power minus 4. So finally we got an answer. This one 7.316 into 10 power 4. Okay. So next, quotient of friction. So you can see Reynolds number, it is greater than 4000. Okay. So we must use this formula. So 0.079 divided by RE power 1 by 4. So here somewhat mistake is there. 0.079 divided by, here on 0 is missing. So divided by RE power, RE is 7.316 into 10 power 4. Okay, the whole power 1 by 4. So finally we got an answer 0.0048. Okay, so finally head loss due to friction. So HF. So from that above we calculated velocity and F. So substitute all the values in this equation. So HF is equal to 4FLV square divided by 2GT. So substitute all the values, we got an answer 163.18 meter. This is the final answer. This is the loss of head due to friction. And one more solution we must calculate. What is that? Power required. Okay. So for power required, we have to use one formula. So you have to memorize this formula. So it is nothing but rho G Q HF. Rho G Q HF divided by 1000. Divided by 1000. So the power unit is kilowatts. K is small letter and W is capital letter. Okay, kilowatts. So here, what are the parameters we don't know? Density. Density we don't know. G we know, and Q discharge we know, and HF. So HF is nothing but this value. Just before we calculate. Okay, divided by 1000. So kilowatts. So how to calculate density? Remember first unit, density. Density is nothing but specific gravity into 1000. Into 1000. Specific gravity. What is meant by 1000? 1000 is the density of water, standard liquid. Okay. So where rho, density of oil is equal to 0.7 into 1000. Okay. So which is equal to 700 kg per meter cube. So 0.7 into 1000 is nothing but 700 kg per meter cube. Okay. So power required, which is equal to, so substitute all the values in this equation. So density we know 700 into 9.81 G, 9.81, and Q is, what is Q? 0.5 meter cube per second, and HF is 163.18 meter. So this is your HF. So finally, power required is equal to 560.28 kilowatts. 560.28 kilowatts. So this is the final answer. Okay, students. So now we will move to the next problem. So this is the last problem in this class. So after this problem, 5 minutes we will discuss your doubts. Okay. So calculate the discharge through a pipe of diameter 200 mm when the difference of pressure head between the two ends of your pipe 500 meter apart is 4 meter of water. Take the value of F, which is equal to 0.009 in the formula. HF is equal to 4FLB square divided by 2GD. So students, here you can see one thing. So in this problem, F is given. F is given. Okay. So what they are asking, calculate the discharge. Calculate the discharge. So we need to calculate discharge. So what is the discharge formula? So velocity into area. Velocity into area. Okay. So we must calculate the velocity first. After that, discharge we can easily calculate. So how to calculate velocity? So using this Darcy's equation only we have to calculate. So let us see how to calculate. So first write down the data given and formula. So here in this problem, diameter of the pipe is given. What is the diameter of the pipe? 0.2 meter. And the length of the pipe, L is equal to 500 meter. Next, difference of pressure head, 4 meter of water. Okay. And F is given 0.009. This is also given. So these are all the data given values. Okay. So now using the equation HF is equal to 4FLB square divided by 2GD. So 4FLV square divided by 2GD. So substitute all the values. So what are the unknown values here? Only V. So all other term. F is known. F is given in the question. And L, length of the pipe also given. How much? 500 meter. And B is the unknown value. And the diameter also given. It is 200 mm. It is converted into meter, means 0.2 meter. Okay. So finally, V is equal to HF also given in the question, 4 meter. Okay. So in this equation, the only unknown value is V. So substitute all the values. Finally, V, which is equal to 0.934 meter per second. 0.934 meter per second. So this is the velocity. Okay. So from this, once you found the velocity, you can easily calculate discharge. Okay. So how to calculate discharge? So discharge is equal to velocity into area. Velocity into area. So velocity is 0.934 into area pi by 4 into d square. Pi by 4 into d square. Okay. So 0.934 into pi by 4 into d square. D is 0.2 square. So finally, we got a discharge. You can see here. Velocity, I substituted this velocity, and pi by 4 into d square. D is given in the question. Okay. So substitute the values in this formula. Finally, we got an answer in terms of meter cube per second. So discharge unit is how much? Sorry, discharge unit is meter cube per second. So finally, we got 0.0293 meter cube per second. Okay. So, but we must substitute discharge in terms of liters per second. Liters per second. So we know that 1 meter cube is equal to 1000 liters per second. 1 meter cube is equal to 1000 liters per second. Okay. So 0.0293 into 1000. Okay, 0.0293 into 1000. So finally, we get an answer 29.3 liters per second. Okay, 29.3 liters per second. This is the final answer. So remember the difference between previous problems and this problems. Okay, so in previous problem, they didn't given F value. Okay, the last 4 problem, they didn't given F value. But this problem, they given the F value. Okay.